Hey guys, it's Joe the Android guy. Why are some quad-core chips not performing as fast as some of their older non-quad-core chips in today's modern tablets and smartphones? That's a very complex topic, but we'll try and scratch the surface in today's Android Guy Weekly. Okay, so let's start with a couple misconceptions. First of all, megahertz and gigahertz aren't everything. They help, but they're not going to influence your speed as much as chip architecture. Second, cores. Doesn't matter if it's dual core, tri-core, quad-core, heptacore, doesn't really matter. Cores help with one specific thing and not for general everyday stuff. And I know that's just made a whole bunch of you bristle, but hang on with me. Okay, so let's go back and talk about topic number one. The first thing we've got is megahertz, or the megahertz myth. The faster you run something, the better it is. That's the myth. And it really is a myth. The faster you run something doesn't necessarily translate into the faster you get things done. In fact, especially when we're talking about mobile, smartphones in particular, tablets a little bit less because they've got such a big battery in comparison, ultrabooks, notebooks, netbooks, all that stuff. The faster you run something, the more power it takes, the more heat it puts off, and the more battery life gets sucked down when you're trying to do that. With a big asterisk there, okay? That big asterisk is to combat that energy sucking, heat creating, run it faster, you have make it smaller. The smaller you can make a chip or an entire system, generally speaking, the less heat it puts out and the faster you can run it, the less power it takes, all that stuff. So if you want to go faster, you've got to make it smaller. If you make it smaller, well, there are some other things that you run into there. But that's the gist of it. You combat your heat, you combat your power consumption by making things smaller. Look at the chips that we have today. I mean, they're the size of a thumbnail, and they'll do what we were doing with desktop processors that were, how big were they? The size of a silver dollar just a few years ago. It's ridiculous how small we've gotten and how efficient we've gotten things, and it really, really is great. Okay, so that's kind of the megahertz myth. That comes into a special importance, let's say, when we're talking about mobile devices, because when you're on mobile, megahertz and gigahertz aren't as important as battery life and efficiency. Now, I don't know if you've ever done this or not, but if you've got a phone or a tablet that will let you go in and look at the processor speed, usually that means you've unlocked it. And you might even be running a custom ROM or a custom kernel at the very least. But you can actually look and see how fast your processor is running. Now, unfortunately, it's not going to let you do it all the time. There are some apps that put a little watermark up that shows you, how fast is your processor running when it's doing process X, Y, or Z. But most of the time, you're just opening up the app and you're looking at it and seeing it its idle state. And that, in fact, is kind of indicative. My Galaxy Nexus, which is sitting right back there, usually runs at about 350 megahertz. I turn it on, I look at it, and 350 megahertz. Whoa, what's going on here? It's a dual core 1.2. Why is it only running at 350 megahertz? So here's what I'm talking about. This is my phone, and it's right now running at 350 megahertz. It's got an interactive governor, I believe, which means it's going to scale up and down as necessary. And there you see it just scaled up to 700 and back down to 350. So it's not doing enough right now that I really need any more processing power than 350 megahertz. So why would we want to have a 1.2? Well, there are cases where I'd need a 1.2. When I'm doing really graphics intensive stuff, video decoding being really core among those, no pun intended there. But when I'm doing video decoding, I've got not only video, which this is an HD screen, so that requires quite a bit just because of the raw number of pixels there. Also the frame rate that's coming in at 29, 30 frames per second. And then I've got audio that I need to decode as well. Well, that's an awful lot of stuff. If we just count it up, there's the operating system and all the idle stuff that goes on in the background, the video decoding and the audio decoding, and then the displaying of that and the playing back of the sound. Well, that sounds like 6 or 8 things, and in that case, it makes sense and really helps out to have multiple cores that I can split all of these processes across. You remember way long ago when you were watching stuff that you're streaming? Well, you'd watch the video and it would sputter and hesitate, and a lot of times people thought that was a problem with their bandwidth, with their connection speed. And sure, a lot of times it was, but even more, people didn't realize this, it was because their system, their processor and RAM and the whole thing working together couldn't keep up with the demands that we're putting on it. So the audio would be choppy or the video would drop frames so it could keep up with all of it, because it just didn't have enough power to run it all at the speed that it needed to be nice and smooth and, well, smooth and buttery like we know ice cream sandwich is supposed to be. So let's look at another analogy here, okay? Let's say I've got a really fuel efficient commuter car. You know, I don't drive very far. I don't drive it on the freeway. I just drive it on the surface streets. It's a 3-cylinder, doesn't have that great of a transmission, doesn't have that great of a suspension or handling or whatnot, but it gets me where I need to go. Fabulous. Well, let's say that this car manufacturer wants things to go even faster. They want to appeal to a bigger group of people that are, well, honestly, they're buying their competitor's car because, holy crap, that one's fast. Well, what do? They take out that inline 3-cylinder engine, they replace it with a V6. Oh, no. Let's go even more than that. Let's do a V12. So they put a V12 in the same chassis, in the same car. You got the same size gas tank, you've got the same tires, the same suspension, the same transmission, everything. It's the same as the old car, just a bigger engine. Now, what's going to happen here? Sure, now you can go, well, let's go back to our analogy first. If I'm getting to work, I can get to work driving 30 miles an hour. I can get to work driving 120 miles an hour. Of course, when I'm doing 120, I'm going to get there faster, right? But I can still get there doing 30. And, well, maybe when I'm driving on the road, it's during rush hour and I'm not even topping out at 30 miles an hour. I'm 20, 15, who knows what, but I can't even max out my little commuter car. So why would I want to have this super fancy car with a V12 or even a commuter car with a V12? I'm not going to be able to take advantage of it. Well, that's one scenario. But let's go back to the car now. In order for me to go 120 miles an hour, I have to have an infrastructure that's built to support that. I have to have good roads. Hey, my 30-mile commuter car works just fine on, dirt roads, which I don't drive on dirt roads, by the way, but you get the point there. To do 120, you've got to have better roads. You got to have better road base. You got to have better pavement, less potholes. Your curves have to be smoother and wider rather than tight curves that you can do at lower speeds. You might have to bank the turns or the curves to be able to keep the car on the road. You've got to have ways for other people to get onto the road and off of the road very smooth and fluidly. No stop signs here on this street, okay? So in this analogy, the infrastructure is the apps. It's the operating system. It's all the stuff that we're running on the architecture, on the chips and whatnot. So if we don't have apps, if we don't have an operating system that takes advantage of and really exploits all the benefits of, in this case, multi-core processors, or in our other case, this super fast car, it doesn't do us any good. It's driving a Ferrari in Main Street during rush hour. It just doesn't make, it looks nice, sure, hey, how about that? But it's not gonna do what the car was designed to do. So back over here, if we have our super cool, souped up commuter car with a V12 in it, it's just not gonna work right. You put that next to the Ferrari on the Autobahn, and that poor little car is probably going to blow itself to pieces because it just can't handle it all. But that's kind of what we're doing. So what do I mean here? Let's switch back over to technology. The Cortex A9 processor is a good processor. It's been around for a while. And when I say the processor, I mean the architecture, because lots of people license that architecture and build their own chip based off of it. Some people are even, making quad-core systems out of it. It really wasn't designed to do quad-core, just like our commuter car wasn't designed to do V12, but they're doing it, and it works, and they've done a little bit better job than I did making my commuter car, because I haven't seen any of them explode yet. Probably won't. But what we've got there is still kind of an older technology. Well, let's come over to the A15. A15 is newer technology. It's faster, it's smaller, it's got all of these added benefits that the A9 never had, but all these companies have been busy building on top of the A9 with more cores and whatnot, that they haven't been able to keep up to speed, or keep up to date rather, with the A15 technology. So an A15 quad core, hey, that'd be awesome, but everybody's building A9 quad cores because it takes a while to bring one of those to market. You with me? Okay, so that kind of answers the question, and this was sent in by one of our viewers. Why is a quad-core A9 so much slower than an A15? Well, it's because the A15 was designed differently. It was designed for the new roads that those smartphones and those tablets are running on, whereas it's kind of more of a marketing gimmick to put multiple cores onto an older architecture, you know, the A9 and whatnot. So what about the Tegra 3? The Tegra 3 is amazing. It's awesome. We saw all kinds of demos and benchmarks, and holy schmolies, that thing just blew everything away. But in practice, not so much. Why is that? Well, the benchmarks and all the demos that we were shown were optimized to run on that Tegra. And all the stuff that's out there right now is not. It's optimized to run on everything that it can run on. If you are an app developer, what would you rather do? Would you rather have one app that runs on everything? And by everything, I mean, we're talking, what, 18 gazillion, I think, is the number of Android users out there. So 18 gazillion people are buying your app for $1, so now you're an 18 gazillionaire. Send some over that to me. I'm Joe the Android guy over at Pocketnow.com. Anyway, so when you're on the other side, you can make your app super awesome with bells and whistles galore and run it on a Tegra 3 and make it look fabulous, amazing, awesome, but you've only got 13 people that are running it. So now, if all 13 of those people buy it, you make $13. Go out and grab a nice lunch. So you see where I'm going with this. We need to have a common infrastructure. We need to have a common core. We need to make sure that the cars that are running on our roads all can run on the roads efficiently and well, but when we need performance, the performance is there. The marketing gimmick is more cores. More cores have their place. They do help. You take that Ferrari out on the track and you're going to love it. But when you're commuting in it, not so much. But when we're going with more advanced chips, you know, the A15, we're getting some advantages there that you might not have by just going with an A9 quad core. Tegra 3 is somewhere between those. It's not really, it's its own thing. It has its own challenges, and it's trying to compete in this whole ecosystem that already exists. It's doing pretty darn good, but it still has room to really take advantage of what it can do. We need to have more apps out there that can take advantage of it, just like we need to have more racetracks out there and more autobahns out there to take advantage of that Ferrari. So I hope that makes a lot of sense, maybe just a little bit of sense for you. Analogies between cars and computer chips don't really hold up all the time, but it kind of helps communicate the differences between them, because more people understand car engines and understand, you know, computer architecture. At least I think so. Maybe not. If that's not the case, let me know in the comments. Okay. Now, a lot of this stuff has been generalized, not specific. So I know that there are some technical inaccuracies between what I've said in the A9, the A15, the Tegra 3, and whatnot. But for the case of making things simpler for more people to understand, that's why I've presented them the way that I have. If there's something that you just can't stand that I said that you think was just completely wrong or would like to clarify, again, please leave a comment down below. Use the time mark so we can go back and I'll reference that. Did you know that on YouTube you can put like 1:14 space whatever, and it'll hyperlink that to that particular point in the video? Yes, you can do that on YouTube. So you guys who are watching the video over at Pocketnow, you can comment down below, but of course you've got to take advantage of the hyperlinking to the time over on the YouTube comments. So about that, this kind of wrapped up 3 user comments into one relatively long video. I apologize for that, guys, but they were all so similar, so related, that I thought I'd just lump them all together. The point that I want to make here is the inspiration for this video came from you. It didn't come from me. It didn't come from anyone over at Pocketnow. This came for you. This Pocketcast is for you. I said Pocketcast. We don't even have that anymore. The Android Guy Weekly is for you. That's why we put so much emphasis on the comments. We want you to comment. We want you to contribute. We want you to ask questions. We want you to send in recommendations for upcoming episodes. I know we can't get to every single one. In this case, we got to about 3 of them. And for those that sent them in, thank you. You know who you are. I appreciate it. Fabulous topic, just so in depth that I hope I did it justice, and I hope I answered your questions for you. Is that good? All right. Leave your comments. Thumbs up the video if you liked it. Thumbs up the video even if you didn't like it, and thumbs up the video if you like fast cars and car analogies. I think I covered everybody out there. Head over to pocketnow.com so you can read the article relating to this video, and to get up to date on news, tips, tricks, solutions, everything that you would want, not just for Android, but for all of the major OSs, smartphones, and tablets alike. For Pocketnow and the Android Guy Weekly, I'm Joe Levi.